Guys, this is our third video solving trigonometric equations using identities. So let's crack on. So the two identities we might need are these guys. You've seen them loads now. And here's the question. So this is off an exam paper, 7 marks altogether, so quite hefty. So it is given 5 cos squared theta minus cos theta is equal to sine squared theta. By forming a suitable quadratic equation, we want to find the possible values of cos theta. So that is telling us then to transform the equation into just cos terms. So we're going to be using the identity sine squared plus cos squared is equal to 1. So we're going to want to turn the sine squared on the right into cos squared stuff. So sine squared then is equal to 1 minus cos squared theta. So our equation becomes 5 cos squared theta minus cos theta is equal to 1 minus cos squared theta. Not quite sure what's going on there. 1 minus cos squared theta. So that's now our equation then. So we want to get everything on the same side. So if we add cos squared, we get 6 cos squared theta minus cos theta. And then if we subtract the 1, we get minus 1 is equal to 0. So that is our suitable quadratic. Now we want to find the possible values of cos of theta. So we need to factorise this. So what do we know? We know the two numbers inside of the brackets have to multiply together to minus 1. So that tells us they are both at least going to be 1. One is going to be positive, one is going to be negative, but we don't know which yet. Now we want to end up with a 6 cos squared theta, so I'm just going to try it with a 6 cos theta term, which makes the other one cos theta. Now can I make this work? Well, the answer to that question is no. So if we did 1 times 6 cos theta and then minus 1 times cos theta, that would give us 5 cos theta, or if we did it the other way around, we would get minus 5 cos theta. So we can't do it with a 6 cos theta term and a cos theta term. So 1 is going to have to be 3 cos theta, which means the other has to be 2 cos theta. So if we were to now put a plus sign in here, so in the first one, so we got 3 cos of theta plus 1. That's now going to give us 2 cos theta when we multiply it. And then if we put a minus 1 in there, that's going to give us a minus 3 cos theta. So 2 cos theta minus 3 cos theta does exactly what we wanted to do and gives us minus cos theta in the middle. So this is then telling us that 3 cos theta plus 1 is equal to 0. So one of our values for cos theta would be cos theta equals, take away the 1 and divide by 3, we get minus 1/3, or this guy over here on the right is telling us 2 cos theta minus 1 is equal to 0. So cos of theta can be add the 1 and divide by 2, 1/2. So those values are what the question was asking about. The possible values of cos of theta. So we've done part A. Okay, then part 2 is asking us to show that possible value of tan theta is 2 root 2. So, how in the world are we going to do that? Well, we're now going to need the identity tan theta equals sine theta over cos theta. So, what we're going to do, we're going to use one of our values of cos theta to work out the value of sine theta first of all. So, we're going to go with cos theta equals minus 1/3. It might work, it might not. So, if cos theta equals minus 1/3, then if we square both sides of that, cos squared theta is 1/9. We know from sine squared plus cos squared equals 1 that cos squared is 1 minus sine squared theta. So 1 minus sine squared is 1/9. If we add sine squared and subtract 1/9, we get 8/9 is sine squared. So if we square root both sides of that, we get sine theta is positive or negative the square root of 8/9, which is plus or minus root 8 over 3, which one more time is plus or minus, root 8 is root 4 root 2, so it's plus or minus 2 root 2 over 3. So we can now say tan of theta is plus or minus 2 root 2 over 3 divided by minus 1/3. So what we're saying there, sine divided by cos. So this can be positive or negative 2 root 2 over 3 times minus, or we flip minus 1/3 over, so it's minus 3. So essentially then, what we've got is positive or negative 2 root 2 times minus 1. Because the minus 3 cancels out with a 3 on the bottom. So that's times minus 1. So our two possible solutions are tan theta equals minus 2 root 2 or positive 2 root 2. That is the guy we wanted to show was a possible value for tan theta. So, mission accomplished. Hope this one's helped. Take it easy, guys.